So second topic is shaping processes for plastics. So these are the main ang sudyod sa aning shaping process for plastics. So let's start. So there are two types of plastics. First is thermoplastics and the second is thermosets. So thermoplastics are the chemical structure unchanged during heating polymer. So polymer melt, high viscosity, viscoelasticity. So thermoset. So what is thermoset? Scoring process during heating, cross-linking of molecular structure. Once cured, they cannot be rem- remelted. Plastic molding is the net shape process. Less energy is required than for metals. Strength to weight rat- ratios for competitive. So this is the diagram of viscosity relationships. So we can see the diagram. So next is the viscoelasticity dye smell example. So this the extruded polymer remembers that previous shape. So this smell as manifestation of viscoelasticity in polymer melts. So this is the flow of polymer di kani. So the dye kani. So the extrudate kani kani. So this is the dx, the viscosity. So this is the viscoelasticity. So extruder for the thermoplastics and elastomers. So this is the diagram. So external barrel, extruder heaters, melt face application, door and window of molding. So this is the diagram. So extrusion die for solid cross section. So this is the diagram. So die cross section obtained. Square extrude profile. So this is the diagram for extrusion die for solid cross section. So next is the diagram of extrusion die for hollow shapes. So this is the diagram. So next is the diagram of extrusion die for coating wire. So cross section of die for coating to electrical wire. So this is the diagram. So next is the picture of injection molding machine. So mao ni ang picture. A large of 3,000 ton capacity injection molding machine. This photo is courtesy by Cincinnati Milacron. So the polymer is heated the first into the mold cavity. So net shape, typical cycle time 10 to 30 seconds. So mold may contain multiple cavities. So the next is the diagram of an injection molding machine. Reciprocating screw type. So some mechanical data are simplified. So money and diagram. So next is the diagram of injection molding cycle. So this is the diagram of injection molding cycle. This is the picture. So next is the picture of two plate mold. So this is the two plate mold. So kanindua. So this is a closed mold has two cavities. Then this is the open. Kani open. This is the closed and this is the open. So next is the three plate mold. So again, this is the closed and this is the open. So next diagram is the toggle clamps and the hydraulic clamps. So this is the picture of hydraulic clamps and hydraulic clamps. So next is the defects of extrusion. So this is the melt structure caused by the turbulent flow. So this is the diagram of velocity profile. The melt through die opening can lead to defects to connect. This is the bambooing. Next is the sheet of films like the extrusion. So this is the picture. So the application of this is the product of wrapping material, grocery bags and the garbage bags. So next is the blue film calendar on spinning. So this is the blown film process for high production of thin tabular film. So this is the sheet out of the rubber rubbery thermoplastics. So this is the melt spinning of the continuous filaments. So next, the diagram of planar coating process. So this is the roll method. So this is the Dr. Blade method. So next is the alternative injection molding machine design. So this is the screw plasticizer. So this is the plunger type. So next is the reaction of injection molding or RIM. So this is the application of this is the bumpers and the fenders. So RIM or the reaction injection molding is the polyurethane parts of process of the foam internal structure surrounded by the adhesives of outer the skin. So this is the diagram. So next is the compression molding. So molding compound available in the several foams, powders in the palettes, liquids are performed. So this is the diagram. So composed and other occurred. Next is the diagram of transfer molding. So this is a plunger transfer molding, rod iPath transfer molding. So this is the diagram. So next is the extrusion blow molding. So number the one extrusion of Paterson. Number two is pinch. The tube of the number three is the tube of inflated. So this is the picture and this diagram. Next is the diagram of other blow molding processes. So injection blow molding. So this is the picture though. The strength below is the molding polyethylene terephthalate or the PE very or the PET very low permeability strengthened by the strength blow molding. So this is the picture and this diagram. So the next diagram is the rotational molding. So this diagram is the rotational mapaano niyo patuyok. So next is the vacuum thermoforming. So this is the diagram. This is the vacuum drone kani. Next is the terraforming. So this is the vacuum terraforming. This is the pressure terraforming. This is the diagram of terraforming. So again, this is the vacuum terraforming. The application of this vacuum terraforming is the boat host and the shower stalls. So may canal terraforming. So next is the polymer foam. So this is the gas pores kaning mga circle. So polymer and the gas mixture porous of the cellular structure, polystrate or the styrofoam. This is the styrofoam or trademark or the polyurethane. This is a polyurethane. So this is the diagram of extruder relationships. So this is the typical pressure of gradient of the extruder and this is the extruder of die characteristic. So so the third topic is the glass working. So glass working includes the raw materials preparation and melting, shaping process of glass working, heat treatment and finishing, and product design considerations. So, glass overview of the materials. So, glass is one of three basic types of ceramics. The other are traditional ceramics and new ceramics. Glass is distinguished by its non-crystalline or vitreous structure. The other ceramic materials have the crystalline structure. So, glass products are commercially produced in the almost unlimited variety of shapes. So, most products made in very large quantities. So, number one is light bulbs, bridge bottles jars, light bulbs, window glass, glass tubing for fluorescent lighting, glass fibers. So, other products are made individually, which is giant telescope lenses. So, shaping methods for glass. So, methods are quite different from these traditional and new ceramics. So, process sequence is shaping glass. Starting material is heated to transform it from a starch solid into the viscous liquid. So, it is then shaped while it is fluid condition. When cold and hard, the material remains in the glassy state rather than crystallizing. So next is the glass products. So glass products are commercially produced in an almost in an almost unlimited variety of shapes. So most products made in very large quantities. So number one is light bulbs, beverage bottles, jars, light bulbs, window glass, glass tubing, fluorescent lighting, glass fibers. So are products covered individually. So which is giant telescope lenses. So shaping methods of glass, so methods quite different. So first sequence shaping, starting material, heated transfer from the solid into the various liquid. It is unshaped while the condition when the cold is hard, material remains in the glass state rather than crystallizing. So this is the diagram of the processing sequence of glass working. So typical process sequence in glass working, preparation of raw materials and melting. Number three is shaping, and the last is heat treatment. So this is the sand, this is the molten glass. So ilan gihimo. So this is the glassware. So the the glassware is here. So number three is heating or the treatment. So balik, this is the preparation. Number two is there's the shaping, and lastly this is the treatment. So raw materials preparation and melting. So principal component is nearly all glasses in silica, ZiO. Primary source natural quartz in sand. So other components are added to the proportion to achieve other desired composition. So the ash source. So this is the limestone. The source is the aluminum oxide. So this is the elements. So the sput and the potash. So this the recycled glass is usually added to the mixture too. So glass melting. So the batch starting material is called charge, and the loading into furnace is called charging of the furnace. So which is the melting temperature for the glass are found into 1000 degrees Celsius to 1600 degrees Celsius to viscosity of molten glass is inversely related to temperature, so which is shaping immediately follows the melting. So temperature at which glass is shaped depends on the viscosity required for the shaping process. So shaping process is the fabricate glass products can be grouped into three categories. So one category is discrete process for the pieceware, where bottles, jars, plates, light and bulbs. So continuous process to making flat glass, shape and the plate glass and tubing laboratory where fluorescent and lights. So fiber making processes to produce fibers for insulation and fiber optics. So shaping of pieceware, ancient methods of handworking glass influence glass blowing. Handicraft methods are still used today of making glassware items of high value in small quantities. So, however, most modern glass shaping processes are highly mechanized technologies for producing discrete pieces such as jars, bottles, and light bulbs in high quantities. So, pasteware shaping processes. So, first is the spinning. So, what is spinning? Similar is the centrifugal casting of metals. Next is pressing. Pressing is the mass production of flat products such as dishes and TV tube faceplates. So, press and blow. Press and blow production is the wide mouth containers such as jars. So, blow and blow. This is the production of smaller mouth containers such as the beverage bottles and the incandescent light bulbs. So, casting. It is a large item such as astronomical lenses that must cool slowly to avoid cracking. So, spinning press sequence. This is the picture. So, spinning and of funnel-shaped glass parts such as scattered ray tubes for TV, and one is gob of glass dropped into mold, and the second is the rotating mold of spread molten glass in the mold. So this is the gob glass dropped into mold. So this second picture is the rotating mold of spread molten glass on mold. So number two is I number pressing of the flat pieces processing sequence. To this is the glass gob is fed into mold. So next is pressing into shape by plunger. The next is the plunger is retracted to finished product is removed. So again, the press and the blow process sequence. So this is the molten gob is fed into the mold cavity. Second is the pressing to form apparition. Next, this is the apparition is transferred below mold, and lastly the blown to final shape. So this is the final product. So blow and blow process sequence. So gab into the mold cavity. So moto kaniya. So pag abot na diri sa fourth partially formed piece of respond the second blow mold. So napunan siya og blown to the final shape. So next is the casting. If molten glass is sufficiently fluid, it can be poured into the mold. Massive objects such as astronomical lenses and the mirrors are made by these methods. After cooling and solidifying, the piece must be finished by lapping and polishing. Casting is not often used except for special jobs. Excuse me. Smaller lenses are usually made by pressing, so shaping of flat and tabular glass, so process for padding flat glass such as sheet and plate glass. So is a rolling or flat plate float process. So process for producing glass tubes, so which is Danner process. So rolling of flat plate glass. So this is the diagram. So starting glass from furnace is squeezed through opposing rolls followed by grinding and polishing for parallelism and smoothness. So this is the molten glass. So next is the formulating of rolls. So this as support rolls kaning gagmay nga circle. So next is the float process for producing sheet glass. So molten glass flows into the surface of the molten tin but achieving uniform thickness and smoothness. So no grinding or polishing is needed. So this is the cooling zone. So kaning puti. So is to annotating. So this is support roll. So katong magligid-ligid po kan. This is the molten glass. This is the molten glass. Next is the Danner process of drawing glass tubing. So molten glass flows around the rotating hollow boundary through which are is blown while glass is drawn. So this is the molten glass flow. So mo ni ang paguman atong process producing of sheet of glass. So this is the Danner process of drawing glass tubing. So forming of glass fiber. So glass fiber products fall into two categories with different production methods for each. So the first category is fabrical glass is the thermal insulation costing. So insulation and air filtration in which the fibers are in a random wall-like condition. So this which is produced by centrifugal spraying. So second is the long continuous filament state suitable for fiber reinforced plastics, yarns, fabrics, and the fiber optics which is produced by drawing. So centrifugal spraying. So in a typical process for making glass wool, molten glass flows into the rotating bowl with many small orifices around its periphery. Periphery. So centrifugal force causes the glass to flow through the holes to become a fibrous mass suitable for the thermal and acoustical insulation. So this is a drawing for the continuous glass fiber. So this is the diagram. So continuous glass is a fibers of small diameter are produced by pulling strands of molten glass through small orifices in a heated plate made of the platinum alloy. So this is the picture. So this diagram. So next is the heat treatment annealing of glass. So heating of elevated temperature of molding to eliminate stresses and temperature gradients, then slow cooling and suppress transformation and more rapid cooling from the to room temperature. So excuse me. So annealing temperature is the 500 degrees Celsius to 900 F. Same function as the metal working stress relief. So annealing is the perform in tunnel like furnace coolers in which its products move slowly through the hot chamber of the conveyors. So next is the tempering of glass. So heating the temperature somewhat above annealing temperature into the plastic range followed by the quenching of the surface usually by a air jet. So surface cool and harden while interior of steel plastic. As the internal glass cools, it contracts putting the hard surface into compression. So tempered glass is the more resistant and scratching and breaking due to comparative stress on its surface, Products windows for to buildings or glass door safety glasses. Case study of automobile windshield. So when the tempered glass fails and the shatters into many small fragments, so automobile windshields are not made of tempered glass due to the danger posed by this fragmentation. So instead of conventional glass in use in the fabricated by sandwiching two pieces of glass on either side of a true polymer sheet. So should this laminated glass fracture, the glass spinner are retained by the polymer sheet of the windshield remains the relatively transparent. So finishing operations on glass. So the operations include grinding, polishing. So iguman sa hapit na mahuman. So this di musud na niyang mga grinding, polishing and cutting. So glass sheets often must be ground and polished to remove surface defects and scratch marks and to make opposite sides parallel. So, in pressing and blowing with split dies, polishing is often used to remove C marks from the product. So, cutting of the continuous sections of the tube and plate is done by first scoring of the glass with the glass cutting wheel and then breaking the section along the score line. So, other finishing operations, decorative and surface process performed the certain glassware products includes the mechanical cutting and the polishing operation, sandblasting, chemical etching with the hydraulic acid often in the combination with other chemicals, so coating, so coating of the plate glass with aluminum or silver the product mirrors. So product design considerations. So glass is transparent in the has optical properties that are excuse me you know unusual is not a unique among engineering materials. So, for application requiring transparency, light transmittance, magnification, and the similar optical properties, glass is likely to be the material of a choice. Certain polymers are transparent and may be competitive depending on design requirements. So, so product design consideration too. So glass is much stronger. The comparison, the tension component should be the design to be subjected to compressive stress, not to tensile stresses. So glass is brittle. So glass parts should not be used in application that involve the impact loading of high stresses that might make cause fractures. So the lastly is product design consideration 3. So certain glass compositions have very low thermal expansion coefficients and not tolerate thermal shock. So these glasses should be selected for application where the characteristic is important. So, design outside edges and the corners which is large radii and the inside corners with large radii to avoid points of stress concentration. So threads may be included in glass parts. However, the threads should be coarse. So this topic is for Vince Randall Rustia.